Hello students, in this video we're going to compute the gradient of a scalar function. Now recall that the gradient operator is a derivative operator that produces a vector, and the components of the vector are the partial derivatives of the function with respect to each of the variables. So in this case, in the first component we have the partial of f with respect to x. In the second component we'll have the partial of f with respect to y, and in the third component we'll have the partial of f with respect to z. So we just stick f inside of the operator, and here's what the vector will look like. So that means we're going to have to compute the partial of this scalar function with respect to each of these variables and then put them into vector form. So let's compute the partial of f with respect to x. And if we do that, we see that the sine function here has no x in it, so it gets treated as a constant. And so we just take the partial of 3x squared with respect to x, and we get 6x. So we'll fill that in to the first component. Next, we take the partial of f with respect to y. And if we do that, by the chain rule, we get the derivative of the inside. That's where the 3y squared z to the fourth comes from. Now the z to the fourth has to come out because it's treated as a constant, so that factor stays out there. And then of course we have to take the derivative of the outside function, which is the derivative of sine, which is cosine. So in summary, we take the derivative of sine, we get cosine, we leave the argument alone, and then we multiply by the derivative of the inside. The derivative of the inside has a z to the fourth in it, that's treated as a constant, and then we take the derivative of y cubed and we get 3y squared. So let's put that into the second component, and I have 3 times 3 is 9, and then I have an x squared, y squared, and z to the fourth. And then I put that cosine y cubed z to the fourth term in. The next term is going to be similar in its computation to the previous term. We leave the 3x squared alone because the z treats that as a constant, that's a factor. And then we take the derivative of sine, we get a cosine. And then by the chain rule, we take the derivative of the inside, the y cubed is a constant, we take the derivative of z to the fourth, and we get 4z cubed. And then I'm going to take that 4, multiply by 3, I'm going to get 12, and I'll get 12x squared, y cubed, and z cubed. And then I box that in, and that is the gradient of the scalar function, where we have the partial with respect to x in the first component, the partial with respect to y in the second component, and the partial with respect to z in the third component. All right, good luck.